Welcome to my YouTube channel. So in this video what I'm trying to do is code intersection over union. So it is one of the matrices which we use during the object detection. So in the figure I have a, a figure named with stop sign, and the green box, and that is the actual the ground truth box that need to be detected. But however, in our model predicted this red boundary box, so we have to somehow calculate what is the precision of this object detection. So in such case, one of the matrices that is used is intersection over union. So in this video I'll be coding intersection over union in the VS Code in Python, and after that, in this video, along with this intersection over union, I'll also try to code no max suppression. That is another matrices that is used in object detection. So let's first start with intersection over union, and after that we'll jump to uh, that no max suppression. So I have something interesting to show, and I'll show that after we finish all this code. So remember guys, this video can be a bit lengthy, so around more than half an hour, I guess. I don't know exactly how long will this video be. So let's start, and let's do the coding. So for this I will be using Visual Studio Code. So you have seen the Visual Studio Code. So what I have done is I have created folder IOUV and no max operation, and I have created a Python file iou.py. So in this I'll be coding the intersection over union code in this Python file. So let's start. So at first what I am doing is inputting numpy, because for mathematical calculation we have to pass this arrays. So for that, numpy as np, and let's create a function intersection yes, intersection. So what we'll be passing is two sets of arrays. One will be boxes prediction, and another will be boxes level. That makes sense, right? So let's do this as a change as a numpy array. Boxes predicts, and boxes levels will be np.array. So what we need is the for any kind of boxes. So if we'll even look here, so what we need is these points. So the edges points, either these are these points, or these are these points, to know the width and height of the boundary boxes of each boxes. So what we'll be getting is so x1 y1 and x2 y2 of both the boxes. So let me do box 1, x1 is equal to boxes predicts, and that would be what I need is the first two the so since we will be passing an array, this will preserve the dimension of the input array, and get the first element of each of the an array. So box x1, what I need is equal to boxes predicts so in this case I need 1 is to 2, so that will get second element. So in this way what we can do it, just copy these and just change y So these will be 2 is to 3 and these will be 3 is to 4. So we can do the same for y1. So sorry, box 2, and in this case it will be changed to boxes levels. So that makes sense, right? So if we even look at what we need is the x1, x2, y1 and y2 should be x1 should be maximum of box 1 x1 and box 2 x1, and x2 need to be minimum of box 1 since it starts from here. So we need the maximum of box 1 and box 2 x1, and for the x2 this element we need the minimum of box 1 x2 and box 2 x2. We know in computer vision the point calculation starts from these ends, right? So let's do that. So x1 is equal to np numpy dot maximum. So what we'll do is it returns the maximum of box 1 x1 and box 2 x1. So we can just copy this, and these will be x2 and these will be y1 and these will be y2, right? So in this case what we need is that will be x2 and that will be x2, and these will be minimum and these will be also minimum. And let's that change to y1 and this to y2, y1 sorry, x2, and let's change this to x2. So after that what we need is we need to calculate the intersection. So um, we know the intersection means the only the area that uh, is present in both the boxes. So if we again look into this, so the intersection will be this area, so this boundary red lines and these, and so the inner square that is present in both the boundary boxes, right? So we need a way to calculate this area, this is called intersection, and the union we also need to calculate the union. The union will be this area and this area. So the union will be, so the green box area and the boundary the red box area, and minus subtraction, we have to subtract the addition of this area to this area to the intersection. In this way we can get the union of these boundary boxes. We have already learned about that in set theory also. So let's code that. Intersection will be, so np of maximum, so maximum of 0 and x2 minus x1. I'll tell you why I am using a maximum of 0 and the x2 minus x1. np dot maximum 0 y2 minus y1. So sometimes there can be two boundary boxes where there is no intersection. In that case what we need is um, we get the 0 out of that. If there is no relation between two boundary boxes, in that case it will return 0, and if there is some intersection, that then it will return the product of x2 minus x1 and y2 minus y1. So we are also doing the edge cases. So let's calculate box 1 area, right? That will be box 1 x2, box 1 x2, I think this minus box 1 x1 into this simply x into y for the area. um, in any kind of rectangle, the area is x into y, so we are just doing this. We can simply copy this and change to x y2 minus y1. So let's do something and do absolute, so that if we get by any chance we get the area is negative, so we don't have to deal with that. um, so for the box 2 area, what we can do is simply copy this, and box 2 box 2 box 2, and this is also box 2. I get we all are making sense after this. After that, what we need is now, since we have the area of both the boxes and intersection value, we can calculate the IOU. Or what we can do is first calculate the union of both the union value of both the boxes. That is box 1 area plus, so it's plus box 2 area, box 2 area minus intersection, right? And now calculate IOU. That gives intersection upon union. And what we can do is for the so that it doesn't have to be, if in case we get a 0, in that case the IOU will be infinite. So in that case, let's case a bias value like that, 1e minus 6. So very small number, just to make sure that IOE doesn't end up being infinite. Now we can just return IOU. Before that, what we do is let's print this, like intersection over union, and this is simply IOU, right? So now call the function. What we intersection over union, what we need is box predicts, like, and box levels. Since we haven't so let's create boxes. Here it predicts, and BOX boxes levels. 1 2 3 4, and then let's keep 2 boxes, 2 3 4 and 5. For this let's do 2 3 4 3 4 and another. So what I'm doing is simply just using the random points. I don't know how these points will look like. Let's do this, and now let's run the function. I think it's work fine. Python 3 mine Python 3 IOU on .py. Okay. Oh, sorry, sad. Both the intersection over union has become 0. What we can do is simply 4 5 5 6. Again it is becoming 3. We need to find a way, right? I don't know why it is returning. I think I have made mistake somewhere. X2 minus x1 into y2 minus 12. Why is it returning 0? Let's print this, right? Print intersection int area intersection. It is returning ouch. Sorry, here need to be y2, right? y2 x1 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 x2 y2 y1 y1 y2 y2 box 1 box 2. Okay, let's try this, right? Again it is returning 0. There should be some values. I have tested these. So 0 1 1 2 2 3 3 4 0 1 1 2 2 3 3 4. Ouch. I don't know why it is returning this. It should not have so np dot maximum box 1 x1 box 2 x1, that is right. Box 1 x2 box 2 x2 box 1 y1 box 2 y1 box 1 y2 box 2 y2, that is right. np dot maximum minimum maximum minimum, that looks fine. y1 y2 x2 x1 y1 y2 x, this also looks fine. x2 minus x1 np dot maximum of y2 minus y1 box 1 area. It's getting a problem. So that is also not the case. It is just for the to get the absolute value. Let's print union, right? Yes, it is great. It is giving the value of union, but our intersection np dot, I think there is some problem right here. I'm not able to debug it. x2 minus x1 np dot maximum 0 y2 minus y1, that is right. And 0 1 1 2 2 3 3 4, 0 1 1 2 2 3 3 4, that also looks good. I don't find any problem right here. So okay, I got it. So let's debug, right? Boxes predicts 0 to 1 1 to 2 2 to 3 to 3 to 4, x1 x, oh sorry, that was the problem because okay, this will have also work. So it is because just of the problem in the value I have given. So I have tested those value upon this one. So here what I have done is the first value will be x1 and second will be y1 and third will be x2 and fourth will be y2. But in the previous code I have what I have written, the I have taken, so first one is x1, second x2, third one y1 and third y2. So if I work if I uh, use the value provided in the given this array as that, then there will be no intersection. uh, that was the whole problem. I think you have gotten it. So if I run this function, what I get is I get this. So for these two pairs of boundary boxes, the intersection will be 0, and for these two there will be a certain intersection, that is 0.14, and for this there will be intersection over union, that will be 0. So let's change the value, right? And see if we get any changes. That is again 0, and I think we can do this. Let's do 1 and 1. I don't think we have been able. Let's let me draw it in the paper. And so 1 1 2 4 4 5. So what we do is 1 2 4 and 5. Let's do that to 3 and 4, 3 and 3, and this will be greater than 3. That will no, sorry, this will be 3 3, and this will be greater than 4. That let's do 6 and 6 4. If we use this, that should be sorted intersection, right? Since I the whole firstly given arrays were just randomly picked. I haven't done anything in the paper. Now I have changed these two values, these two arrays, by drawing two boundary boxes in the copy, and now we can get there is a certain intersection 0.09. So in this we can calculate the intersection over union. So if you like the video, you can, what you can do is simply like and what I don't normally say is to subscribe, but you can subscribe to my channel and share it if you find that anyone can be beneficial with this video. So let's wrap up. I think the video have already been long, and in the next video what I haven't done is I haven't done the nomax suppression algorithm. uh, I will do that in the next video. I think the video have been already been long enough to bore you. um, and we have faced some of the problems in this code during the execution. So I'll do the nomax suppression in the next video, and see you guys in the next video. Hope you like it. Thank you.